Next, we will learn how to use the L'Hopital's rule to resolve the 0 to the 0th power, 1 to the infinite power, and infinity to the 0th power indeterminate forms of limits. Let's recall the fact that we know how to resolve the 0 times infinity indeterminate form by converting it to 0 over 0 or infinity over infinity type, and then using the L'Hopital's rule. Let's do the following example. We start off the process by identifying the type of the limit, which has the infinity to the 0th power indeterminate form. The L'Hopital's rule doesn't apply to this limit yet, so let's denote this unknown limit with letter L. And let's apply the natural logarithm function to both sides of the equation, assuming that both sides are positive. Now, let's focus on finding the natural logarithm of L. Since ln is a continuous function, we can pass it through the limit and then use the property of the logarithms to take the exponent out of the logarithm. We rewrite the product as the ratio, and now we have a limit that has the infinity over infinity indeterminate form to which the L'Hopital's rule applies. After each application of the L'Hopital's rule, we must reevaluate the form of the limit. Since it is not of any indeterminate form, we find the limit by simply performing the arithmetic. However, this is what natural logarithm of L is equal to. To find L, we have to exponentiate e to this power to get the original limit. In summary, when dealing with the 1 to infinite power, infinity to 0th power, and 0 to 0th power, we set the original limit equal to L. Then we apply the natural logarithm to both sides of the equation and find ln of L by passing the function through the limit and using the property of the logarithms to change the type of the limit to 0 times infinity. Then we rewrite it as a ratio to change the type to 0 over 0 or infinity over infinity, and then we apply the L'Hopital's rule. At the end, to get the original limit, we exponentiate e to whatever ln of L we found is. Let's do another example. We start off the process by identifying the type of the limit, which has the 0 to the 0th power indeterminate form. The L'Hopital rule doesn't apply to this limit yet, so let's denote this unknown limit with the letter L. And let's apply the natural logarithm function to both sides of the equation, assuming that both sides are positive. Now, let's focus on finding the natural logarithm of L. Since ln is a continuous function, we can pass it through the limit and then use the property of logarithms to take the exponent out of the logarithm. We rewrite the product as the ratio, and now we have a limit that has the infinity over infinity indeterminate form to which the L'Hopital's rule applies. After each application of the L'Hopital's rule, we must reevaluate the form of the limit. Since it is not of any indeterminate form anymore, we find the limit by simply plugging in 0 into the limit. However, this is what the natural logarithm of L is equal to. To find L, we exponentiate e to this power to get the original limit. We discussed how to use the L'Hopital's rule to resolve the 0 to the 0th power, 1 to the infinite power, and infinity to the 0th power indeterminate forms of limits.